See that faint speck of light gliding across the stars? That's not an asteroid, that's not a satellite, that's a comet called C 2025 R2 SWAN. Captured during my last live stream with just a 90mm Apple telescope and a deep sky camera. It's wild, right? This tiny icy traveler is racing through our solar system, and with a bit of patience and the right image processing, you can reveal its structure, motion and beauty right from your backyard. Welcome back to the channel. In today's video I will walk you through how I processed these comet images in Pixinsight, step by step, using a simple but powerful workflow that works for both beginners and advanced users. Coming from this raw image to this image. And that video showing the comet traveling through space. By the way, I also included timestamps if you want to go to another process within this full tutorial. Just go to the video description and you will find the information and just go to where you want to go in the video. So grab your data, open up Pixinsight and let's bring the comet to life. What you will need for this workflow is kind of a star removal tool. I will talk about this later. I will also show you one or two more tools you can install in Pixinsight. And it would be good if you would have some calibration frames, so bias frames, dark frames and flat frames. On YouTube there are many excellent videos about how to create them. Okay, this is Pixinsight. If you are new here, on the right side you can see some symbols and they represent processes. So these are shortcuts if you wish. So you will find most of the processes, not all of them, but most under process or processes, and then here, somewhere here. And another section we will need is a script, batch processing, weighted batch processing, I will show you, and utilities here, most probably. I already did a long video about explaining how to create those shortcuts, how to save them and so on. So watch this video as well if you are completely new to Pixinsight. And just shortly, one or two more notes. For creating my light frames, I used those settings here. So gain was 100, exposure time was 300 seconds per sub, and in total I did 10 of them, so 50 minutes total integration time. And another important thing is I used a binning 2x2. You don't know what binning is? Alright, since this topic is really important, here's a super quick 90 seconds explanation of binning in astrophotography using these little squares. 1x1 binning depicted as a pink square. Every pixel works individually, capturing its own tiny piece of the sky. You get the highest resolution, but every pixel is also fighting noise on its own. Great for sharp details, not so great when the target is faint. Now 2x2 binning. Here 4 pixels team up and act like one bigger pixel, like forming a superhero squad. You lose some resolution, but you gain a much stronger signal because all 4 pixels combine their light. That means better sensitivity and better signal to noise ratio. And binning 3x3, now 9 pixels merge into 1 megapixel. Resolution drops even more, but sensitivity skyrockets. This is perfect when you really need to pull faint stuff out of the noise, like galaxies or dim comets. So in short, 1x1 binning, best detail. 2x2, balance of detail and sensitivity. 3x3, maximum sensitivity for faint objects. So that's why it's really important, if you're completely new to this hobby or to Pixinsight or to astrophotography, If you used binning 2x2, for example, to create your light frames as I did, you also have to do the same settings for creation of your calibration frames. This is really important. Hey, quick pause. If you're enjoying the content, feel free to support the channel by becoming a Patreon member or by subscribing. Your support keeps these videos coming, so thank you, and now back to the video. Enjoy. Okay, let's start with a quick and dirty one. For the quick and dirty workflow, it's really simple. Just go to Script, Batch Processing, and go to Weighted Batch Pre-Processing. Just click. It will most probably take a few seconds to open. And now you go here, click Lights, and click also here, Lights, and select your light frames. In my case, as I said before, I did 10 of them. Then you go to Flats, also here Flats, and select your calibration frames. I did 50 in this case. Same is true for darks and biases. Once you loaded your light frames, flat frames, dark frames, and bias frames, you can go to Calibration, and here you also can see a resolution of the frames, the binning. As you can see, I have the same binning here, all my bias, darks, flats, and my light frames, and this is important. And you can go to Calibration, Post-Calibration, and you also can see here the total integration time. In my case it was 50 minutes, and this is for a one-shot color camera. So this workflow is really for one-shot color cameras. You can also start with mono images. You have to recombine, and then once you have a recombined image with channels RGB, you can just follow my workflow, which I will show you here. And you just select an output directory. I would call it Comet Stack. Select the folder, and you can also do one more thing. You can go to image integration parameters, click and set the minimum weight to 0. This is especially important for later animations. Otherwise, if you have a value here, it could happen that some frames in between are rejected. And then you are missing a frame in between your animation, and this could look really not really nice, let's say. So set this to 0. Okay, that's it actually. You selected an output directory and just click Run. Just continue and make sure you have enough memory space here. This will take minutes or even hours, depending on the machine you are running, how many frames you have, and which camera you used. I will be back as soon as it will finish here. Alright, it finished in just 3 minutes, a little bit more than 3 minutes. 10 were measured, 0 were rejected. This is really good. So just click Done. Done. Once it finished, you will find those newly created folders here. We will work with this one now, and in the previous video I recommended to delete all the other files here because this really big in file size. Don't do this for this workflow. Maybe you will need this one, but we will definitely use those registered images, so don't delete those folders or files, please. Okay, just go to Master, select the latest one here, open. Now you have the screen transfer function. With that one you can get a preview of a stretched image. It will not be stretched yet, it's just a preview. Click here. This is a kind of a rejection map, we don't need that. This as well. And this is the important one. Just click the new button. And now you can already see something here. As I said before, this is really a quick and dirty one. So for example, this is when I did the live stream, I just wanted to make sure we really captured the comet and so on. So this is to get a first impression. Using this method, Of course, you will get a nice, quite nice raw image. This is raw, but you will see an elongated comet because the comet is moving, and when you stack all the single frames on top of each other, you will get a smear. You can also see I have a gradient, and here maybe, I don't know if you can see this through the YouTube compression, I have a ring here, but this has nothing to do with the comet itself, it's just my setup. Don't panic, we will remove this. And this screen transfer function also leads to a overstretched image. And you also can see a kind of a gradient. This is most probably the case because of the light leak, and the other reason is it was really low in the sky. Okay, let's start processing this. First thing you can do is some kind of a noise reduction. You can use a NoiseXterminator. This is a paid Pixinsight plugin, but you can also use a TGV noise or other processes here to remove noise in your images. You will find the TGV noise here, but now we will use this one, and I highly recommend to buy this plugin. Another thing I will also use is a BlurXterminator later. This is also a paid plugin, but it's really good. If you don't want to pay for both, I would recommend to buy the BlurXterminator because, as I said before, there are also other tools with which you can remove noise in your images. But your decision. Okay, first we will use some kind of noise reduction. I always reduce this to 0.6, let's say. Just apply by drag and drop this triangle. That's really nice. No, this before, after, before, after. Just right click, zoom to fit, close this one. And the second thing I would recommend is to use this go to process, all processes, and click automatic background extraction. Then you go here, target image correction, and here you select correction as subtraction and discard background model, and just apply by drag and drop this triangle on top of your image. Now you will wonder why it's dark. If you never use Pixinsight, just click this, open the screen transfer function. So as I said before, it's under all processes, and here screen transfer function. So this is just a shortcut here. Select your image, click this new button. Now you have a stretched version. Don't panic. As I said, this is a ring, most probably from a light leak, and of course all strange things are here highlighted. So don't panic, everything will be fine. The good thing here is if you compare this to the original one, so this is before automatic background extraction on the left, and on the right there's with automatic background extraction. You have a higher contrast now, the green is more prominent and the stars as well, and so on. Okay, just minimize the original one, maybe we will need it later. Right click, zoom to fit. No, right click and zoom to fit now. You can close this one. Another thing, as I said before, it's overstretched, so everything is fine. Now you can either use, also depending on where your comet is in the sky, which position and which camera, you can go to Script, Image Analysis, and click Image Solver. This will solve the image, plate solve, if you don't know what plate solving is. So it will recognize some star patterns and brightness and so on. And with this information, the algorithm will tell Pixinsight where we are in the night sky. This is just a pre-work for color calibration. In my case, it didn't work really, because it was too low in the sky, and also have some gradients here, but you can try this. Just click here, search. The other thing is maybe it will not find the comet, but you can try. This comet is C2025R2 SWAN, I don't know, but if I search for this one, it will not find the right one, so this is definitely the wrong one, I think. And if you enter the whole name, it will find nothing. You have to try this. but it's not essential for the workflow. But this is really nice to have, because based on the plate solving we can do some color calibration. So most probably it will be easier if you are able to use the spectrophotometric color calibration. But let's try this just to show you. I will select this one. You have to enter the resolution. If you're working with FITS files, those information should be part of your FITS files, so will be integrated, so actually you don't have to enter them. Since I use the CWO SI 2600 MC Pro, my pixel size, I don't know why it was wrong here. It's not 7 point something, but it's 3.76 micrometer. We can try this. Most probably we will get an error message. Maybe it will work with your image, but it really depends on the image quality, position of the night sky, in the night sky of your Comet camera and so on. So this didn't work, but that's fine. Once it worked, in your case, you just go to Process or Processes and click this Spectrophotometric Color Calibration, this one. In most cases you just can leave it like this and just apply by drag and drop. I will not do this because it's not working, because to do the spectrophotometric color calibration you will need a plate solved image. If the plate solving and spectrophotometric color calibration is working in your case, it's even better, but we don't need this really. Now I would do some switching of the image. So first reset the screen transfer function, then the next step is go to histogram transformation. Click this symbol here just to see the peak, because this is important, this is your signal. And for switching, I will show you, it's really important not to clip any data here. That's why we have to display this. And you can open a preview by clicking this symbol. That's really helpful. You don't want to do this blind, because otherwise you will clip some data, and just drag this slider here. Not too much, just a little bit for the first thing. Just apply here by clicking here. Now you will wonder, this is darker and the preview is brighter. This is because you will see a second stretch applied on this preview. You have to reset this. I would highly recommend to do the stretching in parts. Don't do this in one part here, going like here, like this and this. I would not recommend to do this. Do this in steps. So just a little bit more, and at this step it's really important not to overdo it, because here you also control how much stars you will see, and this is also for the final image. Most probably you don't want to have your stars too prominent. You want to have your comet really pop and highlight the whole scenery or image, so don't overdo this, but of course it's personal taste. If you want to see more stars, do more stars. Make it a little darker here using this slider. Don't clip any data here, this is important. Maybe a little bit more. Just apply again, reset. Yeah, I would do a little bit more here, but it's really personal taste as you like it. So okay, you can play around here. Close the preview. Close the window, and now we have a nice background. We don't see this ugly ring and so on. That's really nice. Now I would recommend to separate the stars from this comet here, and for that one we will, as I said before, need a star removal tool. In my case I'm using StarNet 2. This is a free plugin. I already did a video, actually at least two videos about how to install StarNet 2, so please watch my videos. And you can use StarNet 2 or you can use StarXterminator. This from the same guy which is doing or programming BlurXterminator and NoiseXterminator. There's a StarXterminator. This is really good, yeah, but you have to pay for this, and I never really had problems with this free plugin, so it's your decision. Important here, since we stretched this image already, uncheck this one. It will also explain why. Because if you have a non-stretched image, so you did not do the step we did before, you have to check this, but we have to uncheck. And another thing which is really important, click Create Star Mask. Just apply this by clicking here, or drag the triangle on top of your image, and this will take minutes, most probably, depending on your processing power. In my case it's really fast. Now we have an image of the stars and the comet only. What you also can do, maybe if you have some problems after separation or star removal, separation of your stars and your comet, just go to Process, All Processes, and click Clone Stamp. Here, just click Control. You can also increase the radius here. Now you pick a background color, actually a pattern of the background. Just click Control and click the mouse. And now, you can also increase the softness and so on. And then you can just paint here if you have some weird artifacts here or something. So to remove artifacts here, it's really nice to use Clone Stamp. Just do this, and this is important. Click here to really execute this. Otherwise it will not be changed. So I will not do this because I don't have any artifacts here. I usually start processing the stars. First thing I would do for later recombining, I would call it stars. If you want to do exactly the workflow I'm doing, it's essential to call it stars. But you can also modify this later. One thing I really like is to have some colors. Just click to color saturation here. And the step we will do now is to apply the color saturation or increase the color saturation for all colors. Just go here and just raise this bar just a little bit. Apply, reset again, and do the second step again. So same as stretching here, I would not overdo it, and I would recommend to do this in steps. Just raise this a little bit, apply, okay, reset, close. Now you can see this is before, this is after. I don't know if you can see this in YouTube. Now we have a green color here. This is before, this is after. I don't like to have the green, and that's only stars. That's why I would use another process which is called SCNR. You will find a process, all processes, and go to SCNR. And now we want to reduce the green here in this case. So select green, that's the default value, and I would definitely recommend to decrease this, maybe 0.5, 0.4. Just apply by drag and drop. Maybe reduce this even more. Again. Another thing you can do is to remove some strange colors in your images is go to Image, Invert, apply the screen transfer function again with the green, reduce this a little bit, apply by drag and drop. Now go to Image again, Invert, and for me this is looking much better now. That's okay so far. Now you can decide if you really like your stars like that, or if you want to increase the amount of stars. Just open the histogram transformation again, open your preview here. Here you can zoom by clicking here, the square. Just select the region you want by drag and drop. And now we have a zoomed version, or to get the full picture by clicking here again. And now just use the slider again. Maybe a little bit more stars. You don't do like this, because you will clip some data here. You can also make your background darker by using this left slider. Don't clip the data here. Yeah, it's personal taste. It's already dark, so I would not really do much with this slider. Just maybe increase the stars or star size and the amount of stars a little bit. Just apply, close. You can play with this. What we also can see is they are really round. Stars are round, they are not elongated. If you have some elongated stars, and if you also have the BlurXterminator, you can apply this. You can also change the values here, but usually I use the default ones. Drag and drop this on top of your image. This can help you to make your stars rounder, not to have any trails here if you have bad guiding or wind or whatever. But in my case, it would not help, it would do the opposite. So this is after, this is before. So this looks much more natural to me. So I will not use it, but you can use it if you want. Okay, I think we finished this one. Now let's play with the Comet here. Just right click, go to identifier and call this starless. So first thing I would go to curves transformation, open the preview and play with this curve or this line to get a better contrast here. Maybe do like a S-curve, apply by clicking here, reset, maybe one more time, like this, apply, click here, reset. Now you also can zoom in a bit here to the comet, and you can increase the saturation also using the curves transformation here. Raise this a little bit, apply, reset as you like. So this is before and this is after. Higher contrast now, more green and so on. If you do have some artifacts here, for example, this is actually not so bad. We can remove this. For example, if you have some red here, you can either use the gradient correction by process, all processes, and click a gradient correction here. We can just apply this with the default settings. Okay. Now, what you also can use is a game script. This is a script you have to install. I can shortly show you how to install the game script. Okay, very shortly here, installation of the game script. Just go to resources, click updates, manage repositories, and just enter the URL I put in the video description. Just copy and paste, click OK, go to repositories, updates, check for updates, wait a few seconds, and then you have a new update here. Yes, click apply. Yes. We'll take a few seconds and just restart Pixinsight. And that's it. Just click OK. Just go to Script, Utilities, Game Script. This script is really nice to create some mask, and then you click Add. You can also zoom in here with your mouse, for example, and just create this on top of your comet, maybe like that. Just click OK. And now if you would apply this mask, you would see it. To make it smoother, just go to Process, All Processes, and click Range Selection here. Then you open the preview, this is important here, and play with this value first, that you don't have it white. You only want to have this shape now, and make it smoother by the smoothness. Yep, maybe like that. Just click here to apply, close this one as well, and now you have a smooth mask. Just apply by drag and drop this, not on top of your image, but here. Okay, what is a mask? So Everything which is red is protected from the next step we will do, any process, and the black position is affected. In this case, it's not the right direction because we want to decrease red edges, for example, or something on the background. We don't want to affect the comet. So go to mask, invert mask. Now the comet is protected and the background is affected. Now just go to curves again, click the image you want to process, open the preview, and now you can, for example, if you have some problems with red, I don't know if you can even see this on YouTube, but yeah, let's say we have a red problem here, you just can decrease this, and now only the background is affected. Don't overdo this, just a little bit, click apply, reset. You can even make the background darker if you wish. Don't overdo this, just a little bit. If you overdo this, you can also affect your comet. If it's too strong, just apply. Now we can invert again to do some changes on the comet here. Maybe it would be nice. But now you cannot see very much. You just go to mask, show mask, not to show the mask, but it's still applied. This you can see because it's brown here. Now you can go to curves again, open the preview. This is nice. Now just increase this a little bit to make the gradient or make the comet more prominent. Maybe like this, just apply. And also do this in steps. Don't do one big change here. Reset. We can increase the saturation again a little bit more by increasing here the curve. Apply, reset, close, close. I mean, you don't want to overdo this, right? One more thing we can do is to remove the noise again here. Just remove this by using NoiseXterminator. Just apply by drag and drop. Yeah, this is after, before, after, yeah. Little change here. Okay. What you also can do is you can do some local histogram equalization. In this case, it's not so powerful because we have a smear here, but we can try this. This is good for a later step. Just open the preview, zoom into the comet. And now using this slider, you can see we have some effects here. Yes, we do have. I would do like this, apply. So this is before. This is after. This is a little brighter here, right click, zoom to fit. Now we don't need this range mask anymore. Yeah, just close it, and now it's not applied. This is gray or black again. This is looking actually pretty nice. And now we want to recombine the stars of the starless image. Just go to process, all processes. Pick some math here. I already prepared something here as a shortcut, and use this expression here. You can just enter this, combine starless stars. So that's why we needed to rename the images in starless and stars. If you have different names, you can change this here, otherwise it will not work. And this is the operation, is the screen operation, so just to recombine the stars and the starless. Yeah, and you just apply by click here, apply, and now you already can see it. That's really, really nice. So you can close this one, or you can also save this, of course. We don't need this. That's really nice. One thing I actually forgot to do but you also can do this now, is to do a crop, a dynamic crop. This is also in a process, or processes and so on. Because most probably you will have, after stacking, you will have some weird things here, some artifacts on the edges and so on. So go to crop, dynamic crop, maybe zoom out a little bit, and now you can do the cropping here, maybe like this, maybe smaller, as you wish. And this important, click this check mark here. Yes, effect. And this is actually looking really, really nice. Remember, it's only 50 minutes of exposure time. The more you have, the better. You can save this by file, clicking file, save as. This is the Comet stick. This is the first one, quick and dirty Comet. And save this as this file, otherwise you can use PNG, for example. Save, click yes. And that's it for the first workflow for the quick and dirty process. Now let's do the second workflow within this tutorial. It's a high quality still image of the comet. As I said before, this is based on the quick and dirty process. You don't have to follow the whole quick and dirty workflow, but you have to have all the data and the stacked image and the registered files and so on. First I want to show you what we have. So just go to process, all processes, go to blink and just open your light frames you did. So the frames you generated during your imaging. Just open them, use the screen transfer function, under process, all processes, screen transfer function, select your image, click this new button here. Now it's looking grayish, you don't have colors because this image is not debired right now. Just to get an idea of what we have here, click zoom to fit to make it a little bit bigger, and now you can go through each and every image here. You can even select time, see all of them in a movie, kind of a movie. And now you can see what we have here. So now we have the stars stable and the comet is really moving here. This is really nice, and this we will also need for our animation later, and also for this workflow for the high quality still. Now we need two things. The first thing is the stacked image from the previous workflow for the quick and dirty one, the stacked comet. Just open this. And Pixinsight. That's just rejection. We will need this master light. Just go to screen transfer function, click this new button. Now you can see this image here. Make it a little bit bigger. For the workflow, we don't need the comet, but we will need the stars. They are pretty nice. So what we will do is we will remove the comet here. But we will do this later. So you can minimize this, we will need this later. And now you go to process, all processes, blink. And now just go to the folder which you selected as an output. For the first workflow, go to Comet stack in this case, and here you use the registered images. Open this, use those files, and open and blink. Just go to screen transfer function, click this new button, and now we can go through the images. The stars are aligned on top of each other and the comet is moving. And those images we will need for the second workflow. So we will work with those registered images. This is really important now. Just go to process, all processes, and click Comet Align. Now you go to Add Files and open the registered one. So Comet stack from the first workflow and go to Registered. Open those files, this is important. They are also debired now and so on. And now you click just Show First Image. Open the screen transfer function and click the new button to see something here. You can close this again. And what you will do is first zoom in to the comet, and now just click on the core of the comet with your mouse. you can see a circle, green circle. That's really nice. So now we are telling Pixinsight where our comet is. So otherwise it will maybe identify next nearby star as a comet, but this is a comet. Okay, nice. Now you also have a mark here, a pin. Then you go to show last image. We will need the screen transfer function again, sorry. Click the new button. Again, zoom in to your comet and select the core of your comet. Again, circle, really nice. And what you also need is that you will click, select an image. I will use one in the middle from the list here and set as reference. So now Pixinsight will do some kind of interpolation and follow this the path of your comet. And then you just set output directory, comment align, select the output. You can do a prefix or postfix. I leave it as it is. Just apply globally here. And it already finished. Now you go again to process, all processes, click blink, go to screen transfer function again, show a preview of a stretched image. And if you remember, those are our registered images. So the images we used for the comet alignment. Don't panic, those are just clouds. It's my light frames. We will remove this later. But the important thing is here, so those are still the registered images we used for comet alignment. Now you select the images from the comet alignment. Go to Comet stack, Comet align, select all of them. Again, apply the screen transfer function. And now, first thing you will most probably recognize, now you have a black edge here and here. And now you can start the animation. So those are the comet aligned images. Now you can see the comet is stable and the stars are moving. Really, really nice. This material is also important for the comet animation later, so keep the files. And one thing, you can do the animation, this is really nice, but I would highly recommend to go through each and every single frame, because sometimes if you have a really bright light source, bright star or something, street lamp or something, you can have some problems with the interpolation here, and you can redo this later. But first you have to recognize this for your animation, so go through each and every frame here just to see if you don't have a jump cut or jump something here. But this is looking really nice, very smooth. Comet is always on the same position here, so it worked. Very nice. Now we have single images of a comet aligned, and we have stars. Now we have to remove the stars, because we will use the comet from the comet align to do a stack of the comet without stars. We will remove this comet here, the smear, and keep those stars, and then we will add the comet aligned and stacked image of the comet only to combine it with this stars only image. This is the workflow. Just minimize this. Now, of course, you can open your file. Just go to File, Open. Little tip here, if you just double click here, it's the same, Open Files. You don't have to go every time to go File, Open and so on. You can do like this. Select the images you want. I think you know which image we want to use now. Right, the comet aligned ones. Just open one, stretch this image. And now you could open your star removal tool, StarXterminator or StarNet 2 for example, and just apply by drag and drop. And then you would have by creating star mask, you would have a stars only and comet only image. Okay, but maybe you don't have just 1 or 2 or 3 images, but maybe 10 as I have, or maybe 100. You don't want to do this for each and every individual frame. So we will batch process this. And this is actually very simple. Just right click, go to image container, select the files we want to use now, or apply the StarNet the star removal tool now. This is the Comet aligned images. Just open. Then you select an output directory. Within the Comet aligned, I would Comet align no stars. Just select this folder. Now you drag and drop this symbol, this triangle here. You can close this. And if you now take any process, not just StarNet, but maybe any process here, you can just drag and drop this triangle on top of the image container. This means this process, in this case StarNet 2, will be applied to all of the images, and the result will be saved in the output directory. In this case, the images are not stretched now, so this is right. Use linear data, and this is really important. So use linear data, and we don't actually need a star mask here, because we will use the stars from that stacked image later. So only the comet. This is important. So don't create a star mask, and check linear data and apply this to all images. And this batch processing really can take minutes or hours, depending on the amount of images you have, processing power and computer and so on. I will be back once it's finished. And now it's finished. To see the results, go to process, all processes, blink, stretch this image, or get a preview of a stretched image using the screen transfer function. Just click the new button. And you remember those are the Comet aligned images. Single frames. And now after star removal, go to no stars, open, use the screen transfer function again, and now you can see we have our comet still aligned but without stars. Isn't this nice? Of course, what you can still see is the clouds passing, because it was really low in the sky and we had some clouds here, but don't panic, we will remove this effect. You also can see black edges. We will crop this later. So far, so good. Now we have the single starless comet aligned images. Now we want to stack them on top of each other, and a fancy word for this is image integration. Go to process, all processes, and click image integration here. You also can go to image integration and click here image integration. Now we want to stack the single comet aligned starless images on top of each other to get a really nice single comet image. Just go to add files. Now it's important to use your comet aligned no stars images, the one we produced before. Open. Since we have no stars, you can go, for example, SNR here. Another thing I would do is to go to rejection and use this one here. It's actually a modern method, rejection method. If you have some strange artifacts or something, I would recommend to use this. And now you click apply globally. This will take a few moments to process. You will not select any output directory because you will see the single individual frames in a second. Here they are already. Close this one. Those are rejection frames again, but we don't need this. And this is the important one, the integration. Ta-da! This is looking really nice. Now we have a single starless comet aligned image here. And you use your image from the previous workflow. That's actually just a stacked image. So here we use this script, batch processing, weighted batch process, pre-processing. So we have a stacked image with the stars here aligned on top of each other. We have the smear and we have this comet only. And now what we will do is we will remove this smear that we only have the beautiful stars, and we will work with this comet. And later we will recombine those two images to have nice stars and just this comet, a stacked comet here. First thing I would do, is to do a crop here, because you have the artifacts now from the comet alignment and also from stacking. So go to dynamic crop, zoom out a little bit, then you make this maybe a little bit smaller, maybe like this. And this is important now, just drag and drop this, not here but here, because we will need exactly the same format for this one as for this one. Otherwise you will get some problems during recombining. This is important. Just click here and apply this by drag and drop here. You select the other image here, just drag and drop this on top. Yes. Zoom to fit, and now you have exactly the same format here. Nice. First thing I would do is to do some background extraction using the automatic background extraction. Go to subtract, discard background model and apply by drag and drop. Use the screen transfer function. Don't panic, this is only for my setup, maybe a light leak. We will remove this later. So now you can see this is without background extraction and this is with. So higher contrast, more signal, and so on. And we will do the same here for the comet. Now I re-stretched it, so this is looking a little strange, but don't panic. This is just because it's overstretched. Everything is fine. First thing, since we did not stretch this so far, so it's in a linear state, first thing I would do is I recommend to do is to reduce noise using NoiseXterminator, for example, or use the all process TGV Denoise. With this tool you're also able to remove noise. But first let's start with this image, Denoise. I would recommend to reduce this. I do 0.6 usually. Drag and drop this triangle. Okay, you can maybe zoom in a little bit. So this is before, this after, before, after. It's amazing what this tool can do for you. It's really cool. And do the same here. Remove the noise. Isn't this amazing? Before, after, before, after. Maybe we can minimize this one and this one as well. It's pre-background extraction. Work with those two here now. Now I would do some stretch here. Go to histogram transformation, click here to reset the screen transfer function, so not to see the preview of the stretched version now. Okay, that's looking really nice. Wow. Okay, just start with a stars image, for example. Click here to get your signal peak. This is important, not to clip any data. Peak is here. Open the preview. And now, as I said before, do this in steps and don't overdo this, because most probably you don't want to have your stars too prominent, but the comet itself. It's the star of the show. Okay, just apply this by clicking here. Now this is much brighter because you can already see a preview of this second stretch. Just reset. Maybe do one more here, maybe like this. Do again, apply, reset, maybe a little bit more, maybe you can do it darker as well. Maybe like this, apply, reset. It's not about the comet, it's about the stars, so ignore the comet here in this case. This is just about how strong the stars will be. And this is actually pretty nice that you still have the comet here, because you can get an idea about the green and how you want to have it with your stars and how prominent you want to have your stars. I would also recommend not to make it too dark, but it's your decision in the end. Just apply. For me that would be nice and okay so far. And now the comet. Go to histogram transfer. Make sure you have the right image here selected. And And don't clip any data here, reset. Okay, okay. And now I would really remove this comet here from the stars. Just open your star removal tool. Now it's a stretched image, so uncheck this one, create a star mask. This is important because we will need this one for the next step, and just apply by drag and drop. Beautiful. Now this we don't need anymore. Get rid of it. By the way, you can also save your images. At some points, maybe it's important to have a step in between saved. Maybe if you stretch more, you get more noise and you can denoise again. But what I would do is to increase the colors here in the stars, open the color saturation, open the preview and raise this bar here. Also do this in steps, reset, apply again, reset. I would really remove some green here, maybe have some artifacts. For this I'm using a SCNR. It's also here process all processes SCNR, so those are just shortcuts here on the right side. We want to remove green. I would recommend to reduce this to 0.6 for example, apply by drag and drop. And you can already see this is before, this is green. Hope you can see this on YouTube. This after, before, after. I think I would leave it like this. You can also remove some strange colors by image, invert, apply the green again, and image, invert again. Now you can decide if you want to further stretch it. Maybe you can use the histogram transformation again as I showed you before, or you also can do the curves and go to here, open the preview. I would not overdo this. And also do this in step, not just one big step. You're also able to increase the saturation by clicking here and use this line here and do the same as stretching, but this is fine so far. So personal decision, what you like here. The stars are really looking really nice, so round. If they are not, you can use, for example, this paid plugin, it's called BlurXterminator. Or if you have some star trailing, this is excellent, but this is looking really nice. Now let's work on the comet. If we zoom in, we can see we still have some noise here, but first thing I would do is to act on the comet. And to do so, you can either use mask by range selection, open the preview, open this slider, so you can only see the comet here. But if you have some maybe light leaks or amp glow of your camera or some street lamp, you have this one, and so everything you would apply to would also affect this region. Of course you can reduce this, but sometimes maybe it's difficult to affect only the comet. I would recommend to use the script I just showed you how to install. Go to script, utilities, game script, just add, zoom in here and just create this shape here. This will later become a mask, so cover all of your comet in this case. Maybe like this. We will create a mask which is much smoother just to get an idea. So I would do like this, maybe click OK. And now if you would apply this mask here, this would have hard edges. So let's smooth this. Just go to process, all process. And now you can also use a range selection. Open the preview. Use this slider just to see your shape and use the fuzziness to affect your comet but not the background, and to make a smooth transition here. So you decide in the end. And this is really nice because this will only affect the comet or the background and not some strange artifacts you have on the edges or something. Just apply. Reset or close. So this we don't need, but leave it open. And this mask, now we will apply by drag and drop, not here, but here. Now you can see the mask is applied because this was getting brown now. Now everything in red is protected from any process we will apply to this image, and in this case the black one would be affected. Let's do like this, show mask, not to show the mask, it's still applied because it's brown. And now you can, for example, increase the brightness here, clicking here, open the preview, zoom in by clicking here, drag and drop. And now you can make it even brighter. Don't overdo this and do this in steps, I would recommend at least. Apply here, and here you also can increase the saturation by clicking here. I can zoom in again if you want, as you like. It's really personal taste. Now this is looking already pretty nice. Now we have a core here. What you also can use is a local histogram equalization. Just open this. That's also all under all process, local histogram equalization. Open the preview, maybe zoom in, click here, drag and drop. This always starts with amount of 1, so this is too much. I would recommend to increase this, and you can see you have more glow. This is strong, 0, strong, 0. So maybe just a little bit. Apply here, reset. You can do this again if you wish, but I would be happy with this. I don't want to have it too artificial. Yeah, that's actually pretty nice. You can also show the mask and invert this mask. Now the background would be affected. If you have some strange artifacts here, or want to make it darker, or want to reduce red, sometimes I have problems with the red. You can go to curves, open the preview, I use red, reduce this a little bit, just a little bit, apply, reset. And what you also can do is you can make it darker using this. But you can see you will also, at least some degree, you will also have some, if you do this too much, you will have an effect on your comment. So don't overdo this reset. For me it's actually looking really nice. Maybe just a hint. Close. Now go to mask, remove the mask. And for me this is actually looking really nice. So you have your stars and you have your comet aligned stacked starless image. Really nice. One important thing to recombine those images is to rename those by double click here, call this stars, and double click here, call this starless. Now you go to process, all processes, and go to pixel math here. And if you open this, you will most probably don't see this equation here or expression, but I prepared this in advance. So you want to recombine this, and you want to use an image which is called starless and stars. That's why it's really important to rename those images, otherwise you have to change the names here. This is important, otherwise it will not work. And you do an operation as a screen operation, so you will some kind of overlay. Just apply. You can close this, and here you have it. Really nice. So now you have your nice round colorful stars, and you have your comet. One more thing I forgot, I would recommend to do this on the starless comet aligned image, which was on the right side. You can reduce some noise again. Don't overdo this, maybe here. perfect. This is before, after, before, after. It's always amazing what NoiseXterminator can do. I highly recommend it. And now we also have a nice glow here. You have perfect green color here, great color, really nice. So that was before, that's the integration. So now you can also see the color, what we did here on the Comet. That's amazing compared to this one. But especially if you want to compare this to that image here, to that image, it's amazing. So you have a nice dark background, you have nice round stars here. If you drag and drop this on top of this image, you will get exactly the same section here, if you did exactly the same dynamic crop here. So stars are great, reduced noise, no noise actually, it's dark, especially the Comet. It's really nice. Compare this to the stacked image. This is a first step in the quick and dirty method, and this is after. So you have a smear here, and this is really nice Comet. This was after stacking, raw, without processing, and this is a nice image after Comet alignment and so on. And now after we created this beautiful final image with the Comet aligned, I will show you in the next step 2 methods how to create animations of this beautiful Comet. Hey, quick pause. If you're enjoying the content, feel free to support the channel by becoming a Patreon member or by subscribing. Your support keeps these videos coming. So thank you, and now back to the video. Enjoy. Alright, now let's make some cool Comet animations. In the first workflow, I will show you how to make animations where the stars are stable and the Comet is moving. And in the second one, the stars are moving and the Comet is still. So, first one, stars stable and the Comet is moving. Okay, let's start. Just open a file, go to File, Open, or just double click here. And it's important to use the registered images from the stack we just created in the first workflow during this tutorial. Open the first image here, open the screen transfer function, apply the preview of a stretched image. And now first thing I would do is do a dynamic crop in my case, just zoom out a little bit. In my case I make it a little smaller, that it's better for you to see on YouTube. Otherwise you can also, of course, only crop it a little bit also, just to give you an idea. Yeah, like this. And here it's important, that's really important, use this triangle and drag it here. Click this check mark, yes, right click, zoom to fit. Okay, now let's rename this, just right click, set icon identifier, call it crop. It's actually a dynamic crop, but call it crop. That's the first step here. Okay, let's put it here. So it's not stretched yet. I would recommend to denoise it using NoiseXterminator, for example, or go to Process, All Processes, TGV denoise, and that's also working. Reduce the amount here, maybe I do almost always to 0.6, just apply by drag and drop the triangle. This is after, before, after, before, after. I think that's really amazing what this tool can do. Don't panic, it still doesn't look really nice, but it's overstretched, it will be fine. Everything will be fine. Also the Comet, you will have a dark background and cool animation. That's also important, just drag this here, drag and drop, right click, set identifier, it's denoise. Denoise. Okay, that's the second thing we will do on each and every single frame here. But I forgot something, but this is actually a good opportunity to test our settings here. Just double click, open the file again, click here, using the screen transfer function to get a preview of a stretched version. stretched image, then apply the crop. Yes. Then right click, zoom to fit, apply the denoise. That's also working, very nice. And now the part I forgot, sorry. Just go to process, all processes, automatic background extraction. Select subtraction and discard background model. First again, let's drag instance here on process, right click, set icon identifier, automatic background extraction, ABE. Okay, and that's the third process we will do. And yeah, just apply this. Let's see how it looks like. Okay, I know this is just a step in between. Everything will be fine. This is working. Okay, close this, yes. Okay, and what we have to do now is to apply those individual processes to each and every single image. Since we don't want to do this by hand, we do a batch processing. And now I will show you how. Just right click, image container, click here to add your files. Again, this is important. Use your registered ones from the Comet stack. This is important. You select all of them, how many you have. Then you select an output directory here. That's a crop, denoise, and automatic background extraction. Just select the folder. Now you drag and drop this triangle here. Close this. Okay, now we have our images here. So we can either go and click this one, drag and drop it here. Then we have image, and then we do again like this, this. But then you have, for each process, you have individual images. So it would be 10 images, 10 images, 10 images. But we want to do all of them together. So to do this, let's go to process, all processes, and go to process container. And now you just drag and drop the individual processes, okay? So first I will do a dynamic crop, denoise, and then automatic background extract. All the processes, all those three processes are now combined here. And now you just apply those processes to your individual images. This will take some time. Okay, now you have many images here created. Just use the screen transfer function to get an idea about the stretched version or the preview. So they are looking almost the same. So you have a reduced noise, you have automatic background extraction, and you have a crop. All the same size and so on. So that's really nice. If you follow the first workflow, at least the beginning, the part of it, we stack the image. And here you will need some images from this process. Please remember how it looked like before. So those are the registered images. And blink. Just stretch it. Now you can see, yeah, everything is how we want to have it. So the comet is moving, stars are still, and you will also have a greener comet, you will have a darker background and so on. But the thing is, you can see differences in brightness. So if you see this one, this image, and this one, because here it's, I mean, the comet was already pretty low in the sky when I imaged it. Maybe 24 degrees or something. And in addition, it was going down, down, down towards the horizon. So that's why this image, previous one, is darker than this later one. And now you have a difference in this brightness here. And in addition, you also have those clouds. And you can hopefully see it on YouTube, those bands of clouds. Here, you can see it really. So, okay, and we want to get rid of that. And to really reduce this effect, or even almost to remove it, it's really necessary to stretch each and every single frame of those 10, my example, to stretch those individually, because at least I don't know any process which can do this automatically. available at the moment in Pixinsight. So this you have to do, but then you get a great animation, and I will show you now how to do this. Now we can handle the clouds and the differences in brightness for each and every single frame. This is quite time consuming because you have to stretch each and every frame individually. You go to histogram transformation, select your image, click here, that's important to get a signal peak here. Deactivate the stretching here by click here, reset screen transfer function, and just start with one, maybe one in the middle. For example, this one. This will be your reference. Go and open a real-time preview and just start stretching by moving this triangle here. Okay, just apply, reset, do this in several steps. I would not recommend to do this in one step. Maybe like that. Now something important here. Okay, this is the one we stretched now. So now we need to have each and every peak on the same position and to have the same width here. During the first stretch I would highly recommend, because during the brightness the peak is shifting, I would highly recommend not to do the stretch too strong here. So like this. Align this on your window, so don't move the window now. And this is actually your reference. This is the peak you want to have in all images. You see the difference now? Yeah. Okay, just select the second one. Okay, open the preview, make it brighter, apply, reset, move this slider and this slider, just a touch, not too much. And now you always have to compare it to this peak. So now you click our reference image, and this is the reference image here. This is the histogram for this image, so the peak is here. Now compare it to this one. So the peak is too far right. So you have to move this slider here on the left, just apply, reset, and now you can see the peak in this image is now at the same position as this one. But the peak of our reference image, this one, is brighter than this one. So you have to do more of a stretch now. Of course, this will lead to a shift in the image. Okay, now it has almost the same width, but different position. So use this darkness slider again. Yeah, now it's the same position. Apply, reset. Now compare again. So this peak is a little wider than this one, but it's okay. This peak is a touch wider than this one, but the position and the whole thing is very similar. So this is actually enough. This is actually quite nice. Of course, if you want to do it really nice and don't want to see any differences in brightness and so on, of course you can work more on this and put more time into this. But for me that's okay, and just to show you the principle. And this you have to do for each and every single frame. So of course save those files here. And I already created a folder here. I would call it Align Stretched, and I already saved the first one, and now we do the second one, the third one, and so on and so on. I know this is a really time-consuming process, but this will also gives you a really nice animation without differences in brightness and so on. Once you did the align stretch to all of them, just proceed with the workflow I showed you in step 1 and step 2 for still images. So this is exactly the same. So first thing, for example, would be maybe one more denoise. Then use your star removal tool like StarNet 2 or StarXterminator. Then you separate, because it's already stretched, you would uncheck this and create a star mask here. Would have a separate image of your stars and your comet. And then you do the other steps like curves, color saturation, what I can recommend really is at the end to use a local histogram equalization to get more details in your comet and so on. And then you just rename it as I showed you, so in stars and starless. And then you just use your pixel math with this expression to recombine this, and then you have your single images. For the actual animation you don't want to have the Pixinsight file format, but you want to have a PNG, for example. Single PNG files, you go to Script and go to Batch Format Conversion. Then you select your files, maybe those, it's just an example here. So once you loaded all your files, you just change this file format from default to PNG, for example, and then you also select an output directory, of course. Maybe also in the Align Stretch folder, and call this Align Stretch PNG. You select the folder and you just click OK. And this will convert your Pixinsight file format into PNG in this case. Okay. Finished? No, we don't want to do this again. And now you have your PNG files here. This is just an example. Then you use your PIPP, for example. Select the files, just drag and drop them here. And this is important for the animation. I would sort it by date or time. It's important to sort it by time, that you start with the first one and end with the last one. Then you can enter something here. You can, for example, can do a cropping and so on. But the important thing is the animation options, where you can select different things. If you want to have a loop or start forward, backward playing, or whatever you want, go to Do Processing and just select an output directory and then start processing. And this will create the animation. And here you have it. And now I will show you the second animation of the comet, where the stars are moving and the comet is stable. We will use actually exactly the same images as we used during the second process during this tutorial. So you will go, check this, go to Blink, open, and then you will take, so we did the comet alignment here, those files. And then we removed the stars using star removal tool, and we have no stars also. This is what I showed you before. So now let's take those images here with stars. Show a stretched version using the screen histogram transformation. And now we can start this. And this is actually the animation we want to have. So in this second case. So actually we have everything we need, we just have to modify it a little bit. First, let's open one file from the Comet Align, give it a preview of a stretched image here. Now you actually have to do almost the same as we did before. So first we will crop it, most probably, because you also want to get rid of those edges here. Just make it a little smaller, maybe like this. It's important again to save this process here by a drag and drop. We will need this later, and click this check mark here. Yes, right click zoom to fit, or right click zoom optimal. That's the first step, that's a crop. You can right click and rename this crop. Then you will go and do some automatic background extraction. Now you go and click here, target image correction, correction is subtraction, and discard background module. Again, save this or drag and drop this triangle here, because we will need this later, it's important, and just apply this to your image. Close this one. This is just to show you the principle here. We will do a batch processing in a second. Just click, give it a preview stretched version. No, don't panic, this is overstretched, everything is fine. Just reduce the noise using NoiseXterminator. The other thing you can also use is TGV noise here. just again save this here, drag and drop, apply to the image. We will have a dark background in the end and a more defined comet here. Just a second. So you can close this actually and this one. Those are our processes. And this is automatic background extraction, and this one is the denoise. Alright, and this we want to apply to each and every frame, so we will do a batch processing again. This was just to show you the process. Right click, go to image container, open your files. In this case, the comment alignment files with stars. Just click open, select an output directory here, the scrub, automatic background extraction and denoise. Select the folder, drag and drop this triangle here. And now again we will need a process container. Go to all processes, click process container here. And now just drag and drop all the processes in the right order. This is important here. Take this triangle by drag and drop, close this, and now you apply all the three processes within this process container to the image. Click yes, and this will do everything you will need, and this will take some time. Okay, now I've finished. It applied these three processes to all the images now, and now we have to do an individual stretch to each and every single frame. This is necessary because they have different brightnesses. Due to the position of the comet. Later it was very close to the horizon, and also we want to get rid of those cloud bands. And this also leads to further differences in brightness. So let's stretch this individually. At the moment we don't need this one. Here it's important, don't take the first one, don't take the last one, maybe one in the middle. In this case it was 10 images. Those are the three. The last three, maybe I will take this one as a reference. So now you need a reference stretch for the other images. Take your histogram transformation. Now it's really important to check this to see your signal peak. This is really important. Place this window that it's at the edge here, that you can still click this reset button here, select your image, go to real-time preview here, and now let's stretch the image a little bit here. First move this slider, the middle one, apply by clicking here, reset, do this again, but carefully, not too much, and do this in several steps again. Don't do this in one step. And I think that's okay. And now it's important to have exactly or almost exactly the same peak for all the images, for the same individual stretching. So the position is important of the peak. That's why you position your reference image here, so that you have a reference here, the position of the peak, and the width is also important here. Okay, this is the reference. Now let's do the second one. Of course, you should save this. Now you can either save it as this file format, or if you don't want to modify it, further modify it, you can also save this as a PNG to do the animation. I will further process this to really highlight the comet and so on, and increase the colors and so on. So let's save this. Yes. Don't close the first or your reference image, you will need this, and continue with the second one. Now you do the stretch, open the preview. Of course, you need to have the same peak here, peak position and shape. But you can control this or check this by having the equal amount of color and stars and brightness here by eye. And this is just a help with the peak here. So, okay, just select your image. This is important. Not the reference image, but the next one. Open the preview and stretch your image a little bit. You can always check with the reference. That's the reference here. Yeah, let's save this image here. Close the preview. You can check by eye, of course. Yeah, you will actually do the same process to each and every frame. And I will be back as soon as I finished. Okay, now I finished. That was actually the most important part, to have an individual sketch, that you have a dark background, that you have almost no differences in brightness, and that you removed those cloud bands. Now you can process however you want. You can denoise, you can increase the colors here and so on. And yeah, that's up to you. Just one more thing, maybe now you saved all your images as a file type, but this is actually not suitable to create an animation. So now you can open this and save this as a PNG file, but maybe you don't want to do this for each and every single image. So here you also can do a batch processing here, or batch process. Just go to Script, Batch Processing, and select Batch Format Conversion. Select the files. I did some additional crop, denoise and saturation. As a batch, we're using the image container I just showed you. So open those Pixinsight files. Then you have to select an output directory here. Animation for the second animation, so PNG as an output directory, select folder. And here, that's important, change this for the file type you want to have, PNG in this case, and just click OK. And now it will convert all the Pixinsight file formats into the PNG. That was really fast. You want to perform another conversion? No. Now we have it here. Now you can go to PIPP, load your files here, like this. Yep. That's okay, minimize that. And here it would be important to really do the right sorting here by time, starting with the first one and the latest one here. Here you can do different things. You can enable crop and so on, quality and so on. This is important here. So you can also decide whether you want to have a forward, backward play or loop or whatever. Maybe you repeat this sequence, I don't know, maybe 10 times. Output directory, maybe you want to save it as an animation, AVI or SER file. And you can go to do processing, start the processing. And now within the folder of your images, you have a new one. And there's the animation. It's super fast. You also can do this in DaVinci or on iMovie, on the Mac or whatever. And so you can really create a really nice looking animation of the comet. And there it is, the Comet C 2025 R2 SWAN, processed and revealed in all its detail. It's always incredible to think that this light traveled millions of kilometers or miles even just to end up on your sensor or our sensors. Quick little edit note for you guys. While putting this video together, I wanted to mention two things real quick. First, the comet footage wasn't shot under perfect conditions. The weather was really not optimal and the comet was really low in the night sky. It was only about 24 degrees above the horizon, so I had to shoot through a pretty thick layer of atmosphere. It's really low in the sky. You can see that is, and it's going down. You will also notice some clouds drifting through. I managed to reduce them a bit in Pixinsight by stretching the individual frames of the final animation. That would be a tip from my side. The second point, this whole comet capture was actually a spontaneous idea that came up from a viewer's question during my last YouTube live stream. I used a setup with around 430mm focal length, my Apo setup, so a rather wide field. But if you want to try imaging the comet and get more detail, especially in the tail, I'd recommend something closer to 1000mm or even higher focal length. Just a tip. Now back to the processing video. Enjoy! If you try processing your own comet data and also capture this beautiful comet, please let me know in the comments or tag me on social media. And if you're new to Pixinsight, remember every dataset is a story of light, time and motion. The more you experiment, the more the universe opens up to you. By the way, a few months ago I already captured a comet, and if you're interested to see this comet and the video about this comet, please watch this video. Thank you for watching, see you next time, clear skies.